In this episode, we're going to talk about taking your low amps probe and making it 10 times higher resolution. A relatively simple trick I'll be demonstrating here, and at the same time we're going to go through and do some diagnosis on these injectors that I have here on display. So let's get started. First thing we're going to have to do is start up the Zeus. So I'll be using a lab scope portion of that. What I'll be doing is taking the fuel injector, and these are just randomly chosen out of ones that have on cars that have been had injectors replaced because of failure. Plug it into my tester, and then respectively I have a power supply here, and what we're going to be doing is we're going to use this relay as our triggering mechanism, and I'm going to use this test light that is simply going to give a ground signal to the relay to turn it on momentarily. So let's go ahead and give her a shot. I've set the scope up for a single trigger event. So once it's in manual mode, so once the event is occurred, it should lock it in, and so we can look at it. So we'll do it multiple times. We'll fire this injector. I want you to take careful note of what you're seeing on the display. Now we'll move to the second injector. Now if we're reviewing the second injector, we see a slight difference between the two. There's a problem that, and with the way it's currently set up with using, we're coming from the positive side of the battery over to the injector and then supplying to the ground. You can see very simply that the amount of current looks normal, but it does look different than the initial one. Next one here, virtually no difference in magnitude, and ones I'm checking here are out of a General Motors. These are out of a Ford Motor Company engine. Let's do the last one here. Good. Very repetitive. There was something different on that one. Now we're going to go ahead and we're going to utilize what I call a 10 amp turn. It's simply a coil of wire that is wound 10 times, so 10 revolutions. So in here there's 10 strands of wire looped together. And what I'm going to do is I'm going to take the low amps probe. I'm going to hook it up, make sure I zero it. Now I have to set the scope up because we're going to have a 10x increase in resolution and also in output. Currently, we're at 10 milliseconds at 200 millivolts. So I have moved the setting over to 2 volts. I'll move my trigger position slightly up. And let's go ahead and we'll run the array of injectors again. Take special note of the waveform, and first off, the clarity of the waveform is significantly increased. We got rid of a lot of the noise lines simply because we're at a higher resolution and a higher voltage level on the lab scope. So we can see more clearly without a lot of the static noise that's in the way. But there's something unique. As you can see that we're going straight up, and then we go in and we see this little deflection. I will explain that deflection here in a little while. So let's go ahead and look at the remaining injectors. Notice here we got our little dip. Similar but different. Remember, 2 different designs and 2 different wear configurations. We'll go ahead and do the last one. Now, can anybody guess what was wrong with number 4 injector here? This injector, the pintle, is not physically moving. As you've seen on the waveform, you don't see the deflection. You're just simply getting no movement at all. You can also feel it click. That was the reason it was replaced. So you got much higher resolution. This technique works really well, so we'll just start from the top. We simply took a piece of wire, wrapped it around 10 physical times, so everything increased by 10 times, and hooked up whatever configuration you would work for, hook it up for your adapters. So this is the classic 10 amp turn. It's a technique done around forever. I would have to say I've been using this for decades and decades. But utilizing it with the low amps probe is a way of really seeing a magnification of the readings and make a more accurate diagnosis. Well, hope this helped. Make sure you subscribe and comment. And thank you. Have a great day.